All right, so today is Wednesday, December 11th, 2019. We're on the second of the three lessons that we have today, general particular solution. So general because we're not going to find step 4. There are 4 steps to going backwards. This is one of the hardest units out of the free responses because the math that you have to do is it's a lot of it, and you have to kind of remember how to do it. I mean, once you do it the first time, it's like, okay, I can do it a second time, but like, give yourself a month off from doing this and then having to do it again. You're like, oh my God, like I have to do all that math. I don't remember what to do. There's 4 steps and they all kind of rhyme. So there's kind of a way to help you remember. What's our objective today?
Find the general particular solution to differential equation.
Yeah, circle that word general. General because we're not doing the specific yet. Tomorrow we're doing the specific particular solutions. All right, so what do I mean by a solution to differential equations? So a solution is, what is the equation? If you found the equation, you're done. So I could have an equation that's like right here, like a parabola like we saw yesterday. That could be the answer, right? The thing is, we don't know what the c is, what the y-intercept is in some cases. So we don't know if it could be here, it could be here, it could be here. These are all the general solutions. The particular solution, we know the c, and therefore it's just one of them. I'm just going to randomly draw it. No, this one right here. We know, oh, the y-intercept here was at 0, -1. Over here, they could have been anywhere. It could have been an infinite number of answers, so we just say plus c. We don't know what this is, so I do 0, c. Or sometimes I might know the x-intercept. I just need 1 point. If I have some initial starting condition, then I can figure out, hey, I know the exact answer. For example, if I had a bunch of graphs and I said, oh, the answer's out here, like, oh, well, it can't be that one, and it can't be that one. Oh, it's this one down here. Right? So you just need some sort of initial condition to get you going. So in general, your equation is going to be something like y equals something, something on the right, but plus c. That's what we're doing today. We're going to have some constant c. Then tomorrow, we're going to change that to something, something, something equals something, something, something plus a number. Like, I don't know. I'm just going to say plus number. You're going to say plus 2. I'm just going to say plus a number. We'll know what that c is. We'll say, I'm going to actually make it 2 in this case. Plus 2. It might be plus 3. It might be something. But we'll know that by tomorrow. And that is going to be the hard part of finding that number. All right, so what you will see, and you can see this on the back, this is the type of problem that you'll be looking at. Some differential equation. I know it's differential because dy dx, we talked about that yesterday. Dy dx or dw db, 2 letters means I have a differential, and it's an equation because it's an equal sign. So how do we approach this type of problem? And I guess I drew one right here as well. How do we approach this type of problem? There are 4 steps. And I will say, you guys, 100% all of you need to do the first 3 steps in order to do well in the AP test. In fact, you need to do like 1.5 steps to pass the AP test. If you can do the first 3 steps, you're getting a 5 essentially. If you can do the 4th step, it's pedantic. It's like you get that 1 measly point. By the way, I'll talk about scoring. I gave a section for me to talk about scoring. I'll talk about it in a sec. But first of all, you need a fraction equal to a fraction. So I can say a fraction equal to a fraction. Or if you prefer, you can say like box over box is equal to box over box. If you do not have a fraction, make it a fraction. Like if it's dy dx equals x squared, make it x squared over 1. Make it a fraction. Okay, so we have a fraction over a fraction. I should get rid of that. The next thing that you need to do is to then cross multiply. So cross multiply. So let's do that. I already have a fraction equal to a fraction. Let's cross multiply. So let's do the dx times x squared, and I get x. Oh, I should also make a note of saying, usually you want to have the y's on the left-hand side. It won't make you wrong, but it makes it easier if you have the y's on the left-hand side. Yeah, so like y equals, right? Y equals mx plus b. So y dy is equal to, and then I'm going to cross multiply the other way, x squared dx. I have now cross multiplied. So I made sure I had a fraction, check. I cross multiplied, check. The next step is to separate the x and y. So separate x and y. And by that I mean, hey, the left side That's only y. The right side, that's only x. And we've done that. There's no hard thing to do. Sometimes you're like, oh, this is an x dy, and I have to divide both sides by x. Make sure this is a dy. Make sure that's a y. Make sure that's an x. That's a dx. The x's are on the right. Y's are on the left. This is maybe a bad example because I didn't have to do anything, but you'll see it in another one. All right, and the note here, this will happen pretty often. If you have something of the term like y dx is equal to x dy, you will need to not subtract, but divide. So I'll say just divide. Just divide. The most common mistake here is saying, oh, I just subtract y from both sides and I get the y on the right-hand side, or subtract dy on both sides. No, it's always dividing. Every single time you're trying to move things around, when you get to this state, divide.
So first you would divide by y and then you would divide just by x.
Yep, exactly. And then you get 1 over y dy, 1 over x dx. All right, so, and by the way, it's a good time to point out how these all rhyme. Step 1, separate. Step 2, integrate. Step 3, evaluate. Step 4, isolate. You guys need to have those memorized. So let's practice this as a kindergarten class right now. Separate. You're saying this with me. Integrate. Evaluate. Isolate. Now we're all going to say it at the same time. Separate. Integrate. Evaluate. Isolate. Again. Separate. Integrate. Evaluate. Isolate. You have to have these memorized. If you first say integrate first, no, you're doing it wrong. Let's separate first. Okay, so.
I would say if this is actually a kindergarten class, it'd be more like, once they separated my dolly from my other dolly because they were fighting, and then I like my dollies, and then I don't remember the rest.
Okay, so I need to make a story about how y and x are fighting, so I have to have my y's on the left hand
This
side.
is the kindergartners interrupting the teacher to talk about.
Oh, I see, okay. Okay, so we're on to step 2, integrate. So that means I now have this equation right here, just write an integral in front of both sides, the left-hand side and the right-hand side. So I now have the integral of, do I have enough room here? I do. So integral of y dy is equal to the integral of x squared dx. Okay, and whenever you finish doing your integration, let's go ahead and practice it. Integral of y is y to the power of 2 divided by 2. Good. And then on the right-hand side, I have x to the power of 3 divided by 3. And don't forget your, yes, your plus c. Don't forget your cake. Generally speaking, you only, like always, you'll put c on one side or the other. It happens to be easier to put it on the right-hand side. And that's not always true, but that's like, I would say 95% of the time, it will make your life easier by putting it on the side with the x's, the right-hand side. Cool. Just by writing that C, you get a full point. Yeah, just by writing plus C.
If I'm lost enough, can I just put a C and like I'll get a point?
Well, no, you have to actually try integrating. If you integrate incorrectly here, but write your C, you get a point.
So you can just like write random letters like y.
I did K, but
The important thing for this unit, for these types of problems, is if you cannot do step 1, they will give you no points at all. Even if you integrate your functions that are incorrect down here correctly, they will give you 0 out of 9 points because step 1 needs to happen. In fact, if I look at a key later, you'll see in the notes, hey, they get 0 points if they didn't separate their variables correctly. So do step 1 correctly. If you can't do anything else, make sure you know how to do a fraction equal a fraction, cross multiply, and get the y's on one side, x's on the other. That's like 3 points sometimes. That's just passing by doing step 1. All right, we're going to step number 3 now. So we've done integrate. We now need to evaluate, which basically means plug in. So come down here, plug in. And what are we plugging in? In this case, I didn't give you an example, but they'd say, solve for this with an initial condition of something or something. Do I have it down here? I don't. That means all of today's homework, we're doing steps 1 and 2. Tomorrow's homework, we're doing step 1, 2, and 3. And if you want to be really, really cool and do a ton of work to get maybe 1 point, you can do step 4. Here's step 4.
Each step is a point, right? Basically?
No.
Oh, never mind.
It's a little bit more complex, but I'll talk about it so you won't get confused. So isolate, essentially you're just getting the y by itself. So get y by itself. And by the way, I should make a note as isolate. What you're really doing here is you're trying to just find what that C is now. Find value for C. Because after step 3, you've found like the general solution, but you haven't found the specific solution until you do step 4. Isolate, get y by itself. I'll make the note here that you don't really need this. And I'll underline need for the AP test. You don't need it to get a 5. You don't need it to pass it. This step 4, I say it's optional. It makes me cringe because it's like me battling like what's best for getting the high score and what's like mathematically true. You need to do step 4 to be mathematically true. You need to actually find the answer. When you've done step 3, you haven't even found the answer. You found most of the answer. You haven't found the full answer. So my soul is saying, no, make them find the C. But it's like you get 1 point for doing like 10 minutes worth of work. It's not really worth doing. That's why I'm saying you don't need to do it for the AP test. And it's because it requires lots of work for little points. I mean, typically it's going to be 1 point. It might maximum be 2 points. But think about it. It's like even if you don't do step 4 and you still are trying to, you get all of the rest correct, you're getting 7 out of the 9 points. You need a 3 to pass. A 3 out of 9 points to pass.
So like I can like get every single one wrong and just get one right and I'll pass.
For this type of question, yes. Yeah, this is where John Wynn is kind of gamifying this. Like, how do I like only learn the stuff that I need to pass? So, on an AP test, in general, English, math, whatever, what score is technically everything in my book is passing. If you get a 1 because you took the test, and as long as you tried on the entire test, you passed in my book. What do you get credit for? Like in terms of colleges, the majority of colleges will give you credit for what score? 3. So 3 to get credit.
Although a lot of them say 4s.
Well, if you go to like a higher, like if you go to Stanford or something like big, they're like, you need a 5. Or maybe if it's so big, they're like, we don't care what you got because you're going to have to redo it anyway. We're going to teach you the right way. So sometimes they won't even give you credit.
UCLA, Berkeley, and the University of Washington all require 4s.
Okay, I know for UC Davis, some were 4s and some were 3s depending on the type of AP test. And it's really nice to get credit for a class because generally speaking, the way that you sign up for your classes is they give preference to people that have more units. So if you're a senior or you're a 4th year at college, you've taken a lot of classes, you have a lot of units, you get to sign up for classes before the freshmen who are the 1st years that haven't taken classes. That's how priority in registration works. If you want to take that fun class, you better have a lot of units. That means you going into college, you'll probably be able to sign up for before other people just because you have this AP unit. You have a college class, this college level calculus class under your belt. So you get to sign up slightly before your peers. Unless your peers, of course, have taken more AP classes than you and passed more, right? Coming back to this, each FRQ, each free response question, FRQ stands for free response question, is worth 9 points.
And this is the creating the scoring for the whole AP calculus.
This is now talking about AP calculus, yeah. So remember, the first section is all multiple choice, A, B, C, D, not E anymore. They used to have E. So if you ever see old questions that have an E, it's only A, B, C, or D now. So you have a higher chance of getting it right if you just randomly guess, right? But now we're in the second section, free response questions. Each of those free response questions is worth 9 points. You need, or to pass.
High question.
What's your question?
How many more units do you have to do?
There's 9,
There's
right?
9 units?
There's 11.
Oh, okay, 2.
To get a 3, this 3 right here. Say again? Yeah, this is unit 6, and our units are a lot shorter now.
Oh, so that's not even that bad.
So then we're just going to be doing practice for the last like 2 or 3 months, huh?
The last month essentially is all review. Yeah.
What happens after you take the AP test in this class?
Then it's almost like the next week we begin doing interim.
Oh.
But in that week of La La Land, you get to do whatever you want. You want to play Risk every day? Sounds fine to me.
Let's do it.
As long as you take the AP test, right?
Is it
Everyone
the-
in here has already signed up and you paid for it, so like,
Is it the AP exams before finals? Or is it?
yeah, they're like 1 to 2 weeks before finals.
Okay.
And I can show you a calendar really quick too. So calendar coming back here to, here's April. So April, we have our, just so you guys see the end game. In April, you have spring break. You take your first final on this Saturday, second final on that Saturday, third final on that Saturday, and then there's the SAT on that day. This is all in April.
Wait, hold up. Go back up. So after spring break, we have to be here on the 11th, right?
You have to be here on the 11th.
That's important to know because that's the week we're planning to do our senior trip.
Yes, you already signed your contracts for calculus saying you promised to be here on the 11th, 18th, and 25th.
Oh, that's for like
Drama,
practicing.
you
We're practicing, right?
I know, right?
Practice.
It's a final. I'm making you take an entire AP test on the 11th, and another entire AP test
No, I
on the
got you.
18th, and another entire AP test on the 25th. It's good practice.
They're pretty
Yeah.
long though. They're like 4 hours.
I mean,
They're 4 hours of testing, 4.5 hours of being here, because I'm gonna give you a tiny little
I
break.
mean, we still gonna be here for English. So.
I know. That's a 12-hour day. Or last year it was.
At least I get you in the morning, so you're a little bit
12
fresher.
hours on a weekend of testing.
Oh yeah, because you have AP English after you take AP Calc for
Yes.
testing.
Why do we have to come in for 12 hours?
I called dibs. I called it first.
Hers I understand because it's like 4 hours a day. If hers is 12
No,
hours
it's
on
8
one-
hours.
It's 8 hours
It's 8 hours,
altogether.
but it's on the same day as Seville. So
Wait,
That's
so
why-
like right after
You
math,
have like a 10.
we have to
we
go
have English.
to
It's
I don't know. That's Miss Taylor's realm. Anyway, coming back. So we just did those 3 finals, right? Because up until the 2 weeks before these finals, all we do is practice. We're doing final practice for 2 weeks, and then we take the final, and then this whole week we just go over that final. Then we take the next final. The next week we go over that final again. We take another final. The next week we go over that final again.
Those finals like work we've done from like.
It's all this material, exactly. Yeah.
So, or is it like a step harder AP calc? Like what?
It's test level. If you've taken the test, it's those same types of problems. And then coming here in May, so your AP Calculus A, B, and BC, you're taking BC, is on the 5th. So you have this whole week. This is the 27th of April. This is still April. And then finally May 1st. That's the last day of saying, okay, I've done my review for AP Calculus. This is the week that you start your AP testing. So on the 5th, we take the AP Calculus BC test.
You want to write the AP Germans also on that day because I have to take 2 AP tests on the same day.
It's not that bad.
I can say German here too.
Like, how
Well,
many?
because Taylor wants me to take both AP Englishes too, and I'm just like,
Oh, yeah.
why?
Oh, because you get 2 credits worth of.
Yeah, but I'm just like, I wasn't
that's
even
not
realizing
safe.
why do I need to take
How many?
both?
Okay.
Wait,
But anyway, you guys know the schedule now. You know that it's going to be review, and then you take the AP test on the 5th. That's the main thing to take away here. So in order to get a 3 on that AP test, guess how many points you need for each of these 9 questions, or each of these 9 points?
1 point.
3.
0.
4.
You need a 3 out of 9. In order to get a 3, you need a 3 out of 9, and that's assuming you're taking the AB test. If you're taking the BC test, it's even easier. And I haven't looked at the stats for this.
That's the breath. Oh gosh.
You got this.
So, by the way, by step 3, if you've done everything correctly, you generally have 6 to 7 points.
By step, have 6, 7.
By step 3, sorry. By step 3, you'll have 6 to 7 points.
What is?
Which means if you don't do step 4, you can very much get a 5 on the AP test. If you want to do step 4, you can do that though.
What if you like? They know you're doing the right steps. You just did a mathematical mistake. Like.
Yeah, so how do they score that, right?
Yeah.
I will show you. It's kind of a giant topic. I can't talk about it too much today because I need to keep going through the general solution. And I have 2 more minutes left of class because I've gone on off task so much.
No, these are important.
Yeah, we were talking about AP tests.
It is important. Okay, so do I have a fraction equal to a fraction?
Yes.
Okay, so on step 1, label step 1. Step 1 is, shout it out,
Separate.
separate. Label it.
I thought it was cross multiply.
Separate. In separating, we need to cross multiply and then separate them. So cross multiply now.
Talking about the substeps.
So it's
Dx times 3y is
Uh,
3y dx. You just mush them together. When I multiply, keep your dy on the left-hand side. dy should always be on the left-hand side. X times dy is x dy. I have not separated yet. I have x's and y's mixed together. Gross, they're all mixed together. I need to separate them. So, to do that, I'm going to divide the left-hand side by x. Divide the right-hand side by x.
Do we have to? What if we divide by dx and dy? Is that not good?
You can do that as well. That's fine. Oh, actually, no, you can't do that. You can't do that because your dx and dy needs to be in the numerator. So if you do that, then you need to take the reciprocal of each side.
Okay.
And then I also need to divide both sides by
Why?
y. You can divide by 3y or y. I'm just going to divide by y.
I'm so confused.
Oh, you already divided.
And now our new equation is 1 over y is equal to, 1 over y dy is equal to 3 over x dx. We have now done step 1.
Yes.
We are on to step number 2. What is step number 2?
Something with
Integrate.
an I.
2 is integrate. So step 2, I now need to write the integral. So integral of, this is not 1 over y anymore. I don't like fractions.
So it's
Y to the power of,
-1.
there it is, y to the power of -1 dy is equal to 3x to the -1 dx. And then you actually take the integral. What's the integral of y to the -1?
Wait, do we need the
natural.
You had to like
Natural log.
Of y.
Yeah. I'll continue this video. I expect you guys to not only watch the video, but also do the homework by tomorrow.
Yes, sir.
All right, so I'm back. And yeah, so we integrate, this is going to be natural log, so natural log, and then you have to take the absolute value. And that's the part that's going to kind of mess us up here. Absolute value of y, and it's not going to mess us up yet. It will later. And then this one's going to be 3 natural log of x, absolute value of x. And don't forget your plus c. That was step number 2. Then I go on to step number 3, which is we can't do. Like step number 3 would have been to integrate, plug in. I always forget what is evaluate. Evaluate. And evaluate basically means if it gave you some initial conditions, say it gave you something like at, I don't know, 1, 2. Then you say, oh, then I plug in 1 for x and 2 for y, and you can just play with that. And let's say that would be natural log of 2. I can drop the absolute value because 2 is already positive, is equal to 3 natural log of 1 plus c. And then you say, oh, okay. And then you can, just by plugging it in, you get a point. And that's all I'm going to do up till now. Example number 2. Let's go ahead and change this problem. Let's say, let's find this at, I don't know, 3, 5. So if I do that problem, let's go ahead and do the same steps. So step number 1, and you should pause the video now and really try to do this on your own because it's the same steps over and over. Okay, you've unpaused the video now. Step number 1 is to separate. Separate. That means I'm making this -y over 1, and I'm going to now cross multiply. So my dy is going to be on the left-hand side, so I have 1 dy, or just dy. And cross multiplying the other way, I get -y, so this is equal to -y dx. All right, I've cross multiplied. I need to make sure all my y's are on one side, all my x's are on the other. So I have a y on the right-hand side. Let's go ahead and divide both sides by -y. Divide by -y. And my new separated equation is -1 over y dy is equal to just dx. I have separated. Hurrah! All right, so now we need to do step number 2. I think I can do 2 and 3 over here on the right-hand side. So let's do step 2 here. Step 2 is to integrate. So that negative is going to be like on the outside, I suppose. Negative the integral of y to the -1 dy. The negative can be on the inside or the outside, doesn't matter. And on the right-hand side, I just have the integral of dx, or 1 dx. You can kind of think of it. So if you want to put that invisible 1 here, you can. In fact, I do want to do that just to make it clear for the notes how I'm getting to the next step. Sometimes it is confusing, like, you're integrating nothing? What's going on? So I'm going to put a hidden 1 here. Let's go ahead and actually do the integration. So this is going to be, again, natural log, absolute value of y. And don't forget your negative. That was out front. On the right-hand side, the integral of 1 is just x. And don't forget your plus c. And that was step 2. Done. All right. And then step 3 is to evaluate. Evaluate, or just plug in. So I plug in the 3 for x, the 5 for y. So this is going to be negative natural log of 5 is equal to 3 plus c. There it is, all 3 steps. You'll be doing those 3 steps over and over and over again tonight on the homework. I'll see you guys tomorrow. Thanks for watching. Bye.